Alright, we're going to look at a law of signs problem. Specifically, we're going to look at the ambiguous case. If you watched the video, I went through a pretty easy method of finding the second problem, or the second triangle, if it exists. So we're going to kind of work through this one. This is actually number 19 in most of your books, I think. Actually, let's go back to the beginning. It might be a different number in my book, but you'll get to see it in just a second. So here it is. A equals 64, or angle A is 64. Side A is 16. B, side length B, is 17. So we're going to be using the law of sines in this version. When you attempt a law of sines problem, you want, even if it's ambiguous case, like right now I can tell you that this is in the ambiguous case because I have an angle, and a side. Or sorry, an angle, side, side. So when it makes a bad word, it's a bad situation. And as long as it's an ASS or SSA, doesn't matter what order they look at. If you were to draw the triangle out and it follows around that triangle in an angle, a side, and a side, then you're in the ambiguous case. And it may not have two triangles. It could have any of the options. It could have 0, it could have one solution or two solutions. You don't need to do anything any different to start the problem. So this is what we're going to do. We're just going to go ahead and solve this problem just like I would. I'm going to start with what I have, and I'm going to solve for the only thing that I can, which is angle B. I have everything else, so I'll plug everything into the law of sines. I'm going to work that out, and basically I'm going to find exactly find exactly angle B. Hopefully you've done this before at this point. So if we work this out, you're going to set it up like this. Now remember, if you get to the point where it's the sine of B equals the decimal or the fraction, that means you're going to have to use your inverse sign to finish the problem out. So you get to this point, it's 0.95497 equals sine of B. And when you go to this point, if you have, you need to keep at minimum 4 decimal places. Don't go any less than that. I went to 5. So go to 4 decimal places to keep it accurate. So if we take the inverse sine, or the arc sine, whatever you want to call it, of both sides, we end up finding sine of B, or actually angle B, is equal to 72.7 degrees. Alright, the next step is, at this point, you've ruled out the possibility of 0 triangles. You've actually found side or angle B. If angle B exists, and angle A exists, then you know it's very simple. We add those two together, subtract from 180 to find our third angle, so that you know the triangle definitely exists. The question now is, do I have to solve for 2, or have I reached my limit and there's only one triangle? It's a real simple, real quick little way to check that. If you watch the video, the original video, then you already know this. What we're going to do is we're going to go ahead, and the question is, does B2 really exist? And so we do this little simple calculation. What you're going to do is you're going to take your angle that you just found, the angle B, or what it doesn't matter what letter it is, but the first angle you find, you subtract it from 180. Okay? If this triangle exists, if the second one exists, then what you just did, the 107.3, is going to be your second B. But the question is that a possibility? Very quick, easy way to check that is you take the values, you're going to add together the original angle that they gave you with the one that's theoretically B2. If they sum together to give you an angle, or it's not an angle, it's a value less than 180, then that triangle exists. That means there is a second triangle. Now the number, the 171.3, the 171.3 is it's just a way of checking, because you know that when you add the three angles together, it can't be more than 180. And so you have 171.3. Well, you know you've got a little bit left over, 8 point something, that's going to be left over for your third angle. So, at that point, we're gonna use that we found, and we're gonna put that in for B and be done with the other part. So now I know that I have two scenarios. So we're gonna go ahead and create my spaces for that, and it's something that I do for most of my triangles. I write out kind of over here where you see what I need, and I try to kind of accommodate that. Here's what I need to find. I call it B2 or B prime, or somehow you can create an alternate naming system to note that that's the second triangle. And so once you've got that, now it's just two different triangles. You're going to solve the rest of them just like if it were just one. And so let's finish it out. If you add B and A, subtract it from 180, you got the angle C, 43.3. Okay? The next step would be to find C2. Well, that was pretty easy. We kind of already did that almost. It's 107.3 plus A, and we had that 171.8, and we subtract that from 180, and you get 8.2. To finish it out, the only thing we have left is to do, that was a little big, let me shrink that a little bit, there we go. We're going to find the last side length. And there's really no shortcut to this. You're going to set up two different law of sine problems and work them out independently. So C would equal 12.2 here. And let's do the same thing for the bottom one. Sine of 64 over 16 equals sine of 8.7 over C2. Now notice that I used sine of 64 over 16. Anytime that you have the option of using what was originally given to you, use it. Because I could have made a mistake, even simple addition or subtraction, I could have made a small mistake in finding angle B or angle C here, and that would translate through to my problem. I'm using A and A because they already gave it to me. I know those are correct, so at least I'm not going to make a mistake on that part of it. And so we work it all the way out, and you have 2.7 as the third and final part of your second triangle. Okay, and that's the law of sines. You have, or well, the ambiguous case. Make sure, let me go back over that one little part that helps you to determine if it's 1, 2, or 0 triangles. You find the first angle, and the first angle we found was angle B. I went ahead, I added angle B, or subtracted it from 180 first. I took that value, which was 107.3, I added that back to the 64 of the original A angle that they gave me. If that sum was less than 180, there exists a second triangle. If that sum is equal to or greater than 180, then there is no second triangle. End of story. You're done. Find the rest of the first triangle, and you finish the problem. Now, if I get to a point and we're looking at, and you're looking to solve for the very first angle B, and you get an error when you find angle B, well, that's a great indication that there is no triangle. And so you would have 0 solutions at that point. If you need to rewatch this video or go back to the original one has a lot more detail in it. I did that for the very first time, so I'll put as much detail as I thought I could. So go back and rewatch that one if you need the extra steps written all the way out.